Today's topic is two graphs appearing identical on a large scale. And let me explain what I am going to do. Let f of x equals 3x to the power of 4 minus 2x to the power of 3 plus 3x squared minus 5x plus 6. And g of x equals 3x to the power of 4. And what I'm going to do is, these graphs are quite different for numerically small values of x. Let me explain this one. The graph will be something like this. F1 equals 5. So 5. And f of minus 1 equals 19. So negative x and f0 equals 6. Okay, this is f of x, something like this. And the g of x equals g1 equals 3. And g of negative 1 equals 3. G of 0 equals 0. So g of x is something like this. So the graphs of these functions are quite different for numerically small values of x. However, they will be virtually identical for the absolute value of x very large. Let me show you. F of 10 equals... Okay, I'm not going to calculate this one, but this is something 27, something like this. 28. G of 10 equals... So these are a bit different. However, f of 1000 equals... Alright, so because 10 to the power of 12 and 10 to the power of 9 is something like this. So this is almost 3 to the power of 12. And g of x is, of course, g so this one and this one could be very similar. Now, how to prove this one? How to show this one more mathematically? We can show that the graphs of these functions are identical for the absolute value of x very large by the fact that the term 3x to the power of 4 in f dominates the polynomial f for numerically large values of x by examining the ratio of the two functions as x approaches plus and negative infinity. What I'm going to do is this. G of x. If this value f of x over g of x and x approaches plus and negative infinity will be 1. That means where absolute value is very large, f of x equals g of x, or nearly equal to g of x. So what I'm going to do is show this one. Okay, let's do that. F of x over g of x, 3 3x 2 5x plus 6 over 3x to the power of 4 equals, okay, equals 1, okay, 3x 2 plus x to the power of 2 x3 5 plus x to the power of 2. Okay, now if I make x approach positive or negative infinity, this can be 0, this can be 0, this can be 0, this can be 0, because x is placed at the denominator position. So when x approaches positive, negative, infinity, this will be 1. So where the absolute value is very large, f of x is almost equal to g of x.
Absolute, absolute. Product, product. Quotient, quotient.
Sum, sum.
Power, power. Limit, limit.
Approach, approach. Trigonometry, trigonometry.
Tangent, tangent.